today we have another examples which concern with complex numbers. This is very interesting complex numbers expression, which is about simplification. So we need to simplify this expression where we have 1 plus I power 70 divided with also 1 minus I power 70. So this is the power of a complex number. The power of a complex number. When you want to simplify, it's better to put in modulus argument form or in polar form. In the polar form, which is we explained, or in the modulus argument form, which is also called a trigonometric form. So when you want to put in trigonometric form, we say that z, which is equal to always r, then cosine of theta plus I sine of theta. Why? This r is the modulus and this theta is the argument of the complex number. Now, here on the first one, r is equal to what? Let's say r1. It is always square root of a square plus b square, or square root of x square plus y square. While here a is 1 and b is 1. So this is square root of 1 plus 1, which is equal to square root of 2. And r2 also, it is equal to square root of 2. They are the same, because it is also 1 minus 1 plus 1 square. Now, we need to find the argument. Argument of 1 plus 1 plus I. It is equal to what? We say that tan of theta is equal to always b over a. That is how we find tan theta. And then theta is equal to arctan of b over a. And this is equal to what? Our theta here is equal to, let's say theta 1 for the upper one, we call it theta 1. This will be equal to arctan or tan inverse of 1 over 1, which is equal to theta 1 is equal to tan inverse over 1, and this is equal to pi over 4, which is in degrees. When you use calculator, in degrees you get 45 degrees. What about theta 2, which is tan inverse of negative 1 over 1. Negative 1 over 1. B is negative 1 and 1 as a. Then we say that theta 2 is equal to tan inverse of 1, which is a negative, and this is equal to negative pi over 4. This is equal to negative pi over 4. Now, the trigonometric form of the upper one, it is root 2, which is r cosine of pi over 4 plus I sine pi over 4, then power 70, divided with also root 2, then cosine of pi over 4. This is negative, so it is negative I sine of pi over 4, then power 70. Now, we are going to use this power 70 on a complex number. First of all, this power 70 comes to here, so it is root 2 power 70 bracket cosine of this power on a complex number. Normally it is powered on r and it is multiplied to the angle. It is powered, the power of a complex number. The power of set z is powered on r and it is powered on this one. So we get 70 times pi over 4 plus, for this one, I sine 70 times pi over 4. We divide with the same, which is also root 2 power 70 times pi. Cosine 70 times pi over 4 minus I sine 70 times pi over 4. Now, we see that this one and this one simplify. This one and this one simplify. When this one simplified, we get cosine. This and this, it is 5 times pi over 2 plus I sine 5 times pi over 2. Also we simplified. Here also we simplified. We divide with cosine 5 times pi over 2 negative I sine 5 times pi over 2. Then this is a number of cosine of pi over 2. And cosine of pi over 2 is 0. But also any number that you can be multiplied, it is considered an integer. An integer which can be multiplied, it is considered as the rotation, the number of rotation. And the number of rotation, it means that it is coming back to that 90 degrees. So its cosine, it is always 0. Then the sine of this is always 1, because the sine of 90 degrees is 1, and at any number of rotation with integers, the number of rotation with integers remains 1. So it is 1i. You divide with the same as here, it is 0, negative 1i. So this is 1i over negative 1i. When you simplify, you get negative 1. So this is the solution to our equation. So thank you very much. Hope that it is understandable, and hope that you are going to try for using exponential equation. Thank you.